Okay, this will be the finale of the graphical analysis here. What we've already talked about is the fact that when you're given any vector, let's say x equals t squared minus 4t plus 3 in the I hat direction. Alright, if I wanted to graph this without actually drawing up a graph, there's a couple of things that I could do. First thing that would be important would be to determine the slopes at any given point. So, determining the slope, that means that we are taking a derivative here. The derivative of x with respect to time, in this case, is going to be, well, 2t minus 4 in the I hat direction. Alright, the reason 2t minus 4. Any constant out here would just be 1. 2 times 1 times t. 2 minus 1 is 1. 2t to the 1. T to the first here, 1 times 4. T to the 1 minus 1, 1 minus 1 is 0. Now, the derivative of a constant, anytime that you have a constant, you take the derivative of it, it is always going to give you 0. There's no t here, so in other words, it would be considered t to the 0th power. You pull that out in front, 0 times 3 is going to give you 0. So for this right here, I've found what my slope is. This is, in other words, my velocity. Now, if I wanted to try to find out the important values, where this velocity equals 0, I would set 2t minus 4 equal to 0. Alright, I'd have to do a little bit of basic math here. 2 goes into both of those, so t minus 2 equals 0. 2 can never be 0, so that means that t minus 2 has to be 0. T minus 2 is 0. T equals 2. So at t equals 2, slope is 0. So that means that t equals 2 is either a relative maxima or a relative minima. Actually, it's going to be an absolute maxima or minima because there's nothing else that's going to be higher or lower than it. But we'll get into that in a moment. Okay, so t equals 2, slope is 0. Now, to determine what the slope is leading up to this point, I need to pick test points. So let's do test point of positive 1. Okay, so I want to see what happens when I plug a positive 1 in here for t. 2 times 1 is 2. 2 minus 4 is negative 2. So the test point is negative, which means that the slope is negative. Okay, so if I were to set up a number line here, my important point here is 2. Anytime that I am prior to 2, my slope is negative. Alright, let's try another test point. Let's do 3. Alright, 2 times 3 is 6. 6 minus 4 is positive 2. That means that we have a positive here. Alright, so the slope is negative, 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 positive, 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 positive. That means that at this point, t equals 2, I have a relative minima. Okay, the slope goes down, 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 up, 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 up. Now, if I wanted to try to graph this without actually getting into insane detail, what I could do is determine what's going on at that exact minima. Okay, at that exact minima, at a time of 2 seconds, if I plug that in here, I can find out exactly what my value would be at the time of 2 seconds. Okay, so 2 squared is 4. 4 minus 8. 4 minus 8 is negative 4. Negative 4 plus 3 is positive 1. So that means that if I were to try to sketch a graph of this at a time of 2 seconds, I would be at positive 1, and this would be a relative minima. So Notice I've got a negative slope coming to it, a positive slope going away from it, and at this exact instance I have zero slope. Okay? Now, another interesting thing that we can do with this is determine what's called concavity. I'm just going to shrink this down, leave it on the screen, but bunch it up to the corner here. Nope, lost my hat on the eye. Alright, now, concavity, the test that you can get for concavity is you want to take what's called the second derivative test. Alright, now in that case, what the concavity is going to determine is whether we have a shape that is looking like this or a shape that's looking like this. This is concave up, this is concave down. Alright, the best way of thinking of it is if you were to pour water on this graph, would it slow that water down? So if water were to pour there, would it slow down here? Yes, it would eventually cup up and you'd be able to fill that up. If you're pouring it on here, would it slow down for a brief period of time, but then it's just going to pour right off? Okay, so let's take the second derivative test and try to determine what the concavity of this graph is. Okay, so, oh wow, there was another d there, my fault. Okay, so the first derivative was here. Let's take the second derivative. So d squared x over dt squared equals 2 t to the 1 minus 1, which is 0. So that is just going to be a constant. This is a constant, so the second derivative test gives me a positive. Right? Anytime that you get a positive result for your second derivative test, that means that your graph is concave up. Okay? So, when you get a positive result here, that means, therefore, I'll use this a few times in graphing here. Alright, those 3 dots in that symbol right there symbolizes therefore. Therefore, the graph is concave up. Okay. Now this could be important at different points in this. If you didn't want to rely on the fact that you've got a negative slope on one side, a positive slope on the other side, then, well, this is one way of doing it. Right? The other thing this tells you is when it's concave up, that means that the value that you are working at is a minima. Okay? Now, the only other thing that we need to talk about here is the difference between relative and absolute. Alright? A relative minima or maxima means that it is not going to get bigger or smaller in the very close range around it. Relative means relatively close, or the range near it. An absolute maxima or an absolute minima means that in any time that this graph exists, positive infinity to negative infinity, anywhere, that means it is never going to be larger than or never going to be smaller than. Okay, now this should get you set to do the third homework assignment. The worksheet for that is on the web page. Now I've placed it 2 different places. I've saved the file itself on the assignments tab, and I have also put a link to it on the calendar. The link to it currently is not too pretty, but I am working on making it look a little bit better. If you guys have any questions or problems with this homework, please see me as quickly as possible. Once we are done with this assignment, that is going to wrap up this chapter. So please get this done ASAPly, and we will get rolling from there. Good luck, and let me know if there are any problems.